All right. Hello and welcome to Bug Free Productions. I'm Isaac Busted, and I'll be helping in this tutorial to learn how to make a brick breaker. So we'll look at some basic physics stuff. We'll look at some basic movement and some just hiding and managing assets in game modes, or not game modes, but gameplay. So first things first, we're going to start with our ball. So let's go over to our full screen view, maybe. There we go. Full screen view. And usually I take a tour around the environment quick, but I think today we're just going to jump right into it. So you can see some extra folders here. So if you need an install guide, go ahead and look that up. Lots of people have already done a really nice job of making install videos for Unity and Visual Studio Community. I'm going to skip that one uh, and just get right into the Unity part of it. So if you follow those install instructions and create a new project, we have um, one of them that gives you is assets folder is your top level folder. If you look at your project window. So here's your project window. And under assets, you'll have scenes by default. So these are packages I've imported and we'll go into that later. But then the last thing we need to do is just create two new folders. Prefabs and scripts folder. So to create a folder, all you have to do is hover over in the project window, right click, create folder, and you can give this a custom folder name. Custom folder. And if you don't name it right the first time, you can always right click and rename, or my preferred method, F2, and then you can edit the name. So again, that's right click, create folder, new folder. I'm going to delete those two just to keep my thing clean. I made these folders ahead of time because I usually get partway in and then realize I have no folders. So let's go ahead and create. From assets, we go into scripts by double click, right click in the project window. So now we're in scripts and we want to create our C# script. So what do we want this to do? So we're going to think about this as our ball. Let's go ahead and we're going to need one script for the ball, one for the paddle, one for bricks. So let's go ahead and just make those. Ball. Again, we right click, create, C# script. Paddle. And we'll create C# script. And this will be brick. We'll create many more, but we know this is kind of where we're going to start with, that we're going to have these three components essentially. So we go ahead and create those. We're actually not going to jump into the script right away. I just wanted to make sure I had those set up. So if we go back to assets, we can see the whole project now. We'll see now that we started filling in scripts with some things, this folder image itself becomes filled in. And we can navigate our project that way. Since we're starting a new project, pay no attention to this. This is just kind of a mock-up I was doing to test some colors and stuff. We'll be getting into colors and other things later. Right now, we can just double click our scenes folder that should be created by default. Sample scene is the default scene that loads when it's when a project is created. So we have sample scene here. So let's go ahead and create a new scene. So we do it much the same as the other folders. We do right click, create, and then scene. This is probably the hardest part is just reading through all the menus. Scene. And we'll call this game mode one or game scene one, something like that. How about game level one? Game level, game level one. And with game level one, then once we've created it, we can double click it and we'll get taken straight to the new scene view. So you'll notice in a new scene, there's the name we named it, there's the main camera, and there's the directional light. These objects are created by default. Um, main camera will probably do a little bit with, and directional light. So this is a 3D project. Um, Hence we have our main camera is a 3D perspective, and our directional light points in this certain direction on the Z. Um, Lighting's a bit complicated and probably won't go into that in this tutorial. But for our first start, we can go ahead and left click and then right click and do a create. And we want to create a 3D object that is a cube. So we're going to create our three objects that we need for the game. So essentially our ball, our paddle, and our brick. So if we create a cube, then I'll just move this down so it's in view. Maybe, is it not? Okay, so you'll notice this transform over here on the cube. So if we select the cube and look at the inspector, then look at its transform, it's very far on the x-axis, the y-axis, and the z-axis. So if we just want to put it towards the middle of the scene, we can right click on the transform, then reset. I have like a little thing caught in my throat. Apologies. So there's this now centered object. I'm just going to move it down a little bit so that we can fit our ball and our brick in here in the same game view. I like to preview things in the game view because it'll render a little bit differently than over in your scene view. So you'll notice scene window over here and game over here. If at any point your windows don't look like mine or have changed, you can always go to window and you can go to where is it? General. You can find some of your general ones here. So some of your general windows, and you can open that, such as the console, project, hierarchy, inspector, game, and scene. These are the ones you'll use most often. And we'll keep going with that. Additionally, there is layout up here. So if you ever want like the basic view that's very default that a lot of tutorials use, you can just go up here to layout and then go default, and it'll reset everything to the default. So now you'll see game and scene are separated or are in the same group of tabs rather. I like to drag my game over into the side. So again, that's just dragging the tab out like you do in Windows, putting it over here. Couple other things to set up a project. I like to keep a 16:9 aspect because I'm usually always designing for a computer. So 16:9 is like the default monitor and screen type. So I like to just keep that constant. Um, it allows me to deal with the pixel sizes elsewhere. So now that we have a cube in game level, we probably need some other things in here. So what else do we need? We can rename this cube by clicking and going to the inspector name and going cube and replacing the word cube with something more like paddle. And if we have something more like paddle, then what? That just marks it nice for us. We could possibly do, not really. Some applications you can change default material color, but not in this one. So we're going to use paddle, directional light. Let's go ahead and right click again. We're going to right click again and we're going to get our 3D object that is a sphere. So this is going to be our ball. I'm going to leave that one there. And then I'm going to right click. You can either right click and create another cube. Um, or since I already have an object in here, I'd probably Control D and then just zip that up. Because sometimes when you create objects, they go very far in terms of world coordinates for some reason. I think it's based on your camera a little bit, but I'm not certain. So creating that that way just lets me know where that thing's going to be located at. Then I can also rename this into something like brick. Um, and once we have a brick, so you'll notice none of these are very distinguishable visually. Um, we'll get to that in a moment, just so that we can tell what the things are visually on screen, not necessarily making them pretty yet. But until then, let's go ahead and check out our scripts. So we have a paddle, a brick, and a ball. So by default, our scripts, if we go back down to our project window, go to our scripts, um, we can do, we can just drag our scripts on. So paddle to paddle, um, brick to brick. What I like to do and prefer to do instead of that is actually to um, click on the object and do that in the inspector. So in the inspector, we can go down to the bottom. If we shrink material, we can see more. So all of these are clickable and collapsible. So we don't have to look at all those properties all the time. But you'll notice down here, there's an add component button. So if we hit add component, we can type in this little search bar that appears, ball, and you hit enter on the object you want to select. So we added a ball script. This is because all the C# classes we generate by default are mono behavior when we do it through Unity. So these things can be added to game objects with, like our ball. Every once in a while, it's a good idea to go into the hierarchy, especially if you're working in it, and just hit Control S. You could also save using the file system that I'm not familiar. Yeah, there's one right in save. I almost never even open this window anymore. Um, but if you prefer graphical, there's always options for that. So these three scripts, let's go ahead and open them. So I have Visual Studio installed, and I'll be using Visual Studio for all of my all my tutorials because I think it's just easier to use. So just double click the script in Unity in your project window, and it'll take forever to load, but this is normal. So up at the top, you usually want to put comments. If you're working entirely by yourself or on a small project where people aren't editing each other's code, and you can tell that I'm doing this way too early in the morning as I can't spell anything or can't type anyways. Um, and then we're gonna go something like that. Control S to save. Optionally, you can put namespaces in here. Namespaces have worked a little bit better. Um, in Unity these days. The only problem I would say is if you work on a team and you're not communicating namespaces, they can lead to other problems. But that's more of a team communication issue than a Unity issue. So just remember to talk to anybody on development teams. That includes game designers, developers, and artists. All three need to know what's going on with the code, the art, and the design to create a functional workflow or the most optimum workflow. So here we see void start and we see void update. I don't really like any of these, so I'm just going to get rid of them. Probably cover what on start and update do later. But for current, we're just going to look at ball. What does ball need to do? Um, Not technically anything yet. So we would say like we need to drop the ball, right? Uh, Double slash just gives us a comment, so we can type whatever we want for notes in here. So why does drop the ball have a thing, right? We don't really need to drop the ball. We can let physics take care of that. So that's a Unity thing that we can let do. What else does the ball have to do? The ball has to hit a brick. Well, we might need to do something here. Um, well, let's not focus on it yet because we can't, because the actual collision can be handled in Unity. So let's come back and take a look at that. It's a good idea just to lay out your code a little bit so that you have some idea of where things are going and where things would be accomplished. So um, with that, now that we've talked about the ball a little bit, let's go back into Unity and show you some of those things I was talking about dropping the ball. So to make the ball fall, you'll notice if we hit play, these objects just kind of stay in place. No physics was acting on them whatsoever. To make physics act on an object, we actually need to give it a rigged body. So we need to rig it. So to rig an object, we're going to, or add a rigged body. Rigging's a little bit different. So to add a rigged body to the ball, we select the ball, and in Inspector, we add a component, and Unity provides us with a rigged body component. So a rigged body component, a lot of automatic defaults, which are perfectly fine for this game. It's not going to be uber complicated physics simulation, although you'll notice these constraints. So if we're going to add force in certain directions, we probably want to uh, freeze the rotation so that the force is always applied in the same way. One thing that we'll actually want to do is freeze the rotation, but we'll want to do this in code just because I like to have it done in code versus in this, because sometimes your metadata gets lost, and if your metadata gets lost, that means that this will unlock possibly, and you'll have additional problems. So let's leave that blank for now. You certainly can fill it in, but it won't make a difference once we do the code for this, which is actually very simple. So the ball needs a rigid body. This will allow it to fall. So if we hit play again, you'll notice the ball will fall to the ground. Cool. Or fall to the paddle rather. So now that we verify it falls, we'll notice that there is a collider. So on the sphere collider, colliders in 3D all have a material that is a physics material, not a graphic material. So let's take a look at what that would be. So let's go up to our assets folder over in our project window. And this is why when people go and create a folder, um, why I don't really like to use the word material in my folder names. Because if we do a material, we can create a physics material in here, but we can also put graphic material in, or we could have graphic material in here, which would actually be kind of a pain, right? So I usually like to separate mine out a little bit. So like my graphic, um, if I was to name a graphics folder, I would probably choose something like the word textures. Um, Alternatively, it could just be graphics. Which does kind of, you just want to make sure that your naming is um, unique and has some sort of system. So I'm going to continue with textures. And I'm actually going to go and create another folder for just for physics. So just for physics, and then I'm going to open my physics folder. And then we're going to right click, create, and physics. Physics material, physics material. There we go. It's right under timeline and signal above GUI skin. So physics material or physic material. Then I'm going to rename this ball phys. PHYS. And we'll notice that this physics material also has information in the inspector that we can change. We have dynamic friction. Um, we'll leave friction on. Bounciness. So dynamic friction, static friction, we can leave alone. Then I'll put bounciness 1. Then friction combine, average. For illustration purposes, let's put maximum. And we'll hit play. So we should see it bounce between these two cubes. Okay. Let's try. Well, of course it doesn't work. You'll note because we didn't actually put this physics object on anything. So once we go to ball and we move to our collider, so you can either drag this physics object in here, or what I like to do, because it's more accurate, is simply to click this little radial here, which opens a submenu, and we can add our little physics object to it. So click once, it does select it, but if you double click, takes our window away and leaves us with that nice look. So if we hit play now, we see it does bounce, it picks up speed as it bounces. And eventually it'll start ping ponging between those two if we leave it long enough. So, given enough force, this ball should remain bouncing at all times. Um, and then once we do that, we probably want to check that sort of thing. So I mentioned add initial force, like adding an initial force to it. So that's probably something we want to do in script. We don't want to necessarily do that in the editor. Could be kind of a pain because we'd either have to like drop it from a certain height or mess with the mass of the object. So let's go ahead and skip on over. Um, it's also worth mentioning before we do that, that physics objects can have multiple, like you can create as many as you want. So we could create ball physics 1, physics 2. If, for example, you wanted to allow multiple settings for a playtester to playtest, see which one feels better, looks better, etc., for different kind of physics settings, this is one way that you can easily set that up for quick swapping, which is kind of nice for making the game pieces modular. Uh, with that, we're actually going to go back and focus on our ball script. So going to the assets and then to scripts. Alternatively, if you have good enough eyesight to be able to read this, um, you'll notice file structures. You can actually just dig down and look through the multiple objects in your hierarchy. So as we look at that, we'll continue with our setup and we'll move on to our ball. So double click to open ball back in Visual Studio. And I'm just going to check our time clock real quick. Being that our time clock is, so we're about half hour in, everything should be pretty straightforward so far, but we will keep on looking at some different things. So um, I mentioned the initial force. So initial force, and what do we mean by initial force? We want to add an initial force so that that bounce has actual power when it bounces off the paddle for the first time, right? We don't want it to simply drop, um, because it could take a while for the ball to reach the paddle. Um, the other option of solving this problem is to make the paddle do more like increased force to the bounce. So we'll look at adding both of those in a little bit, just to make it altogether function a little smoother. So this will be making the ball fall quickly. So we're going to start with our method. Basically, we're going to start with how do we make the ball fall quickly. So we're going to make a method. So you can make comments. A lot of people do. We'll do it up here as an example. A lot of people do something like variables, then methods, then accessors. Um, and then these are basically the three sections that you use most often. Um, that's all fine. Actually, usually in industry, it's more like here. But for me, I like to have them in the variable method accessors order just because that's the order in which I usually end up editing things in Unity. Um, we'll probably talk about a different way of organizing things later. just so that there's not too much weird stuff to remember. So we're gonna make the initial force fall quickly, and we're gonna do that in our methods section. And I am gonna move this accessors back so that I can read in my terrible habits. Um, and we're gonna need a not a public method. We can actually use a private method. Private, and then this method is gonna be ball. I'm just gonna call it something simple like ball initial force. Ball initial force. And with that, there are no parameters. This is not going to return anything, so it can be a void. So we need a private method that returns nothing named ball initial force that takes in a parameter of nothing. So this essentially on and like the start of the game, we want it to add the force down. So what do we need in order to add a force? Well, we need a force to add to that object. So what I'm actually going to use is to create a different variable up here. Um, since I'm not planning on expanding this too terribly much or editing the scripts in place, um, I'm going to use private variables instead of my usual protected that you might have seen on the other video channels or video tutorials. We're going to do private and we're going to need something of a vector 3. Vector 3 just representing positional, like directional information, forward, left, right, up, down, and then this will be initial force. We'll default it to vector 3 as 0. And then I'm actually going to go before private. Um, before we move on, vector 3.0 is literally just a method that returns a vector 3 of 0, 0, and 0. You can think of that as and then I'm actually going to use square brackets here, make this serialized. Once this is serialized, it'll show up in the inspector. So let's actually take a second and go view that, validate it. So if we go back to Unity and we go back to our ball and then go to our ball script, you'll notice that the initial force has been added to the Unity inspector and it has 3 values. For demonstration, I'm going to change y equal to -1. No, let's do -40. Um, I'll explain 40 in a minute, but essentially it's enough force to move it. So let's head on over to our Visual Studio. And in our Visual Studio, we'll see nothing has changed because we didn't really change anything in the inspector or in here. But initial force, so we want to get our rigid body. That's where our object exists, right? So I'm going to do another variable up here. So let's first of all kind of label this. Um, so this field is initial downward force on ball. And we also need the, I can't spell rigid body. There we go. So we make a private rigid body because we only need this class to access it, this very specific object. And then do we want this to be serialized? Well, we could do it serialized. And I'll show you both just for demo purposes. Serialized field, private rigid body. And with the rigid body, we're going to go ahead and just call this RB is kind of like what most people usually label this. I'm going to set it equal to null just because I'm very afraid that someday they'll change how defaults work. So assigned value of null, much like we assigned value of vector30 up here. Because RB is nullable, and then we know that it will be null if nothing overwrites it. So if we go back to Unity, we can see the on the ball, we could see this new field show up, and we just have the ball one. So the ball is selected. So now it'll reference that rigid body on the ball. So what's the other option? So if I select none, we can go back to our code. And if I have none selected, then we can just simply, in our methods, it'll have to be a little bit different. So I'm going to set up references on enable enable. So why do I set them up on enable? Because if on enable runs when an object is enabled versus on like scene start, you can run the enable method once a scene has started, whereas start and awake don't really have that option. So they get a little less usable for certain use cases. So we're just gonna go ahead and make private void on enable, and our on enable is going to be rb.getComponent rigid body. So if we get the component, that essentially says, hey, look at the object that this mono behavior is on. Does it have a rigid body? Cool. This RB variable is now equal to rigid body component on this object. That's all that means. There's one more thing that I'll do to show you the other RB code. So now that we have this rigid body reference, if we do RB dot freeze rotation and set that equal to the Boolean of true, we now have the rotation entirely locked X, Y, and Z. So the ball will no longer be able to rotate, which means we can apply force in direction uh, in terms of world space. So you don't have to think about a secondary like rotation for your ball or anything, which is quite convenient, especially when you do character controllers, because you want to do in terms of other directions, not in terms of your characters facing rotation necessarily. Um, so we have this. So now our ball cannot rotate. Um, And this will all happen on enable. So let's label this even set up RB. And this will be set up um, force. And in here, we're actually going to call ball initial force with parameters empty because it doesn't need any. And with that, we can go ball initial force, just checking time. Uh, Ball initial force, and we're going to move on to actually adding some force to this ball. Um, just making sure we haven't broken anything. Let's go ahead and jump down to our Unity, hit our play button, and observe behavior. So shouldn't do anything different, should just fall and bounce still, but we should at least get that. So now that that's verified, go back to um, Visual Studio. And with Visual Studio, we're going to go to initial force. And I'm going to use RB dot force dot add force uh, and just add the initial force. So this basically adds it as a force mode dot force. So when you add force, you can use this is the direction, the -40 force we want to add. And then, but if we put a comma in here, we'll notice we can also add a force mode to this. So we can use force mode, and we can use dot force. Um, but I don't want dot force. I actually want impulse, which is a single impulse of force. So this will happen once and not apply over, you know, it won't be like an average of force over time, which is kind of how behaves. So, or at least how it looks like it behaves. It might be a little more complicated than that. But with that, we can go ahead and jump back to our Unity now that we have our ball initial force and it's called, and it's just adding force right there. So if we switch back into our Unity, and then go play, we should see yeah. It adds that initial force of 40 and then it just keeps bouncing really fast and fast. Um, you notice it struggles to keep up a little bit. One way we can kind of fix that is to go to our Visual Studio, and in here, we'll probably need a method or something else. I like to put all my Unity methods up at the top. Um, so that's like on enable, start, awake. And what we're going to use right now is fixed update, private, void, fixed update. Wherever you're using it, fixed update. Fixed update is by default where the physics takes place at 50 frames a second at equal intervals. So using fixed update, we can by default edit on the physics frame. And when we adjust our physics, that's where we want to do it. So if there's two ways to think of this. So we could either limit the max velocity that something can go, um, or we cannot allow it to accelerate uh, past a certain speed. So both would be good things to do at any time you can, specifically since we're adding an impulse to this, since there is an impulse involved. Let's focus on that didn't autocomplete in a nice way to type. Um, let's focus on the limiting first, because we don't want it to overspeed past on that first impulse. So fixed update if RB. So how do we get its speed? We get its speed by its velocity. So if the rigid body velocity is greater than, let's say 25, just for a placeholder, if rigid body is greater than 25 velocity, then RB dot velocity dot magnitude um, magnitude multiplied by, let's use the numpad, multiplied by our 25 is what we want our new velocity, a vector 3, I'm gonna call it nvel for new velocity, and make it equal to the rb dot velocity dot magnitude multiplied by 25. Not quite right. Not magnitude. I need the other thing of that. I need not its magnitude, but I need its, I might have to just dots. If we scroll through, if you're like me and just totally forget all the methods that are on a single thing for some reason, you can scroll through here and check it out. So RB velocity of a new velocity is going to be its normalized. I would write scripts for these if I had the time, but who knows when that will be. Let's also change this velocity. We don't want it to be a velocity. That was a mistype. This is a magnitude. Yes, my brain has a lot of times where it just blanks out and quits thinking. Let's try, it also can't spell. Magnitu. Is it the velocity's magnitude? Yeah, velocity dot magnitude. Because magnitude is a vector 3 method and not a rigid body method. So we need the velocity magnitude to be greater than 25, where we create a new vector 3, new velocity equal to rb dot velocity dot normalized multiplied by 25, which is our max speed. Um, so this just limits it from going over 25. Why 25? After 30 units a second, things, or at 30 units a second, uh, colliders start to phase through each other and not work normally. So we go ahead and add this little extra thing to it to ensure that we're within normal physics, um, and everything collides nice. So we save all this up and then head back over to Unity. We can see a start and we can see a play. Um, which it might not be hitting that necessarily. It might be going slower than that. So let's go ahead and change R25 to something like, come on, try one more, literally one more. So it might be the bounce and the initial kind of contributing to that. So private void fixed update RB velocity. So if the rigid body velocity magnitude is greater than 1, oh, actually, it's because I missed this last line. It's going to be velocity. We need to reassign our velocity. So our RB velocity is equal to n vel. Now why can't we, you'll notice some, like, if you do a lot of programming or even just a little programming, why can't we put RB velocity equals RB velocity dot normalized by 1? Um, well, logically that makes sense, but something about the way it's written, possibly because it's a struct, it does not like to do that. It works way better if you just completely replace vector threes than if you try and edit them in place. So um, at least it does with velocity type things. If I were to do this, there was a long period of time where there was a large issue with the code erroring. So it's much safer to create a new variable of a velocity and then reassign it than it is to set the velocity equal to itself in any way, even if you have other operations going on. It technically shouldn't, but it does. So we're gonna go ahead and play. You'll notice it did initial force and then slowed immediately to 1. So if we go to that one and okay, so now we could up it to 25 and we'd probably see an actual difference. Um, you'll notice that each time we did that, we had to come back in here and change it manually. So what I would actually recommend doing, going up here, creating something like maximum velocity. So this would be a private. And while we're here, probably just do serialized. So serialized field private. Max capital VEL, max velocity. Set that equal to a float. A float that is a 30, less than 30. So we can set it equal to 25 by default, or people in the inspector can change it to be whatever. So this is probably our big test point for the ball. Getting physics going. Um, I didn't. So copy that and paste that over where the ones are down in fixed update. And then we can go ahead and the do another test and see if things changes like we expect. Boom. So 25 might still be kind of fast if you're trying to move your ball thing underneath bricks and stuff. So if we go to our ball objects, we go 25. Maybe let's go down to like 15, and you can just kind of play around with that until you're happy with how it works. Other thing I would recommend, that looks better, as well as I don't really like this -40. That seems to be a little jarring, so let's try a -10. And you can see down here in freeze rotation that if we stop, freeze rotation is not set, and then if we hit play, that freeze rotation piece of script runs, freezing that. Our ball is running at 15 units per second maximum, are using our bounce, and starts at initial force of -10. So that's all set up and working. Essentially, our ball is now working. So at this point, I'm going to go ahead and wrap up for this video. So now the ball's working, and we'll work on the paddle and the brick in the next couple videos. So until then, see you then.